Hello everyone, my name is Shafi. Today in this video we are going to discuss about SIP protocol. So let's see what chapter objectives we have in this. The first overview of SIP, what is the advantages of SIP, next SIP architecture, and how many different servers we have in the SIP server, that's the SIP servers, and the call flow. So that's call flow again, similar to MGCP and H.323. In H.323, we have three types of call flows. So here also we have three different types of call flows. Next, SIP addressing. Then finally, SIP request and response messages. What different request and response messages we have. Then we go to the configuration part here, this one. So overview of the SIP. So SIP stands for Session Initiation Protocol. Okay, it's a ASCII text-based application layer control protocol that can be used to establish, maintain, terminate the call between two or more endpoints. So it's a signaling protocol, right? Signaling protocol means to establish the connection from one end to another end. So the protocol, signaling protocol we use. SIP also, now H.32 MGCP also similarly signaling protocol. SIP also signaling protocol. But it's a ASCII text-based. Text-based means it's a clear text protocol. See, what is the difference in H.323 and the SIP? One difference. So the H.323 comes into the hexadecimal format, and this SIP comes into the text-based, clear text-based. It comes here, and it works in the application layer. You know, application layer. There are totally 7 layers we have in the OSL layers. In which layer the SIP protocol is going to work? On the application layer, the SIP protocol is going to be work here. This one. Okay, it is developed by IETF, Internet Engineering Task Force. This is an organization where they have developed this SIP protocol. The same organization, they have developed HTTP protocol also. You remember in the web browser, we use the HTTP protocol. Okay, the same organization, they have developed the HTTP and SIP here. And it works based on the request and response transaction. Request and response transaction means if anybody requests anything, then it's going to be respond. Similarly, HTTP also. HTTP, how it works? It works based on the request and response. Someone is requesting, it's going to be respond here. Here also in the SIP, if someone is requesting something, then only it's respond. If no one is requesting, then it will not respond anything, this one. If you get a request, then only you'll get the response transaction here, this one. Okay, and this is the peer-to-peer protocol. H.323 also peer-to-peer protocol, and SIP also peer-to-peer protocol. But MGCP is client-server protocol. That means always MGCP, okay, if when you are configuring the gateway, always it depends on the call manager, okay, because the gateway will be act as a client and your CUCM will be act as a server, okay. But whereas in the SIP protocol, what happened here? Peer-to-peer. It will not depend on the call manager. So it is individually, it can be work individually, call can be, it can be terminate, it can be generate the new call leg, okay. So that's the reason it's a peer-to-peer protocol here. Next, users in a SIP network or identify by using the SIP addresses. A SIP address is similar to an email address, and it is in the format of SIP:user ID at gateway.com. The user ID can be either a username or E.164 address. Means how you can be identify, the SIP address here. So always it comes in the form of email address. Okay, but what happened here? So here you can see this one. This is an email address. It looks like an email address, user ID at the gateway.com. So, but here before to this, it's going to be at the SIP here, SIP:, then user ID. So here user ID means either if you have created a user, okay, associated the user, it will be give the user ID. If there is no user ID, or it will be give the number here. E.164 format means plus country code, then area code, subscriber number. This is how it will be coming, and the gateway.com. So here the gateway.com is it's a domain name. Okay, either it comes a domain name or it comes with the IP address, this one. But generally here, for an example, plus 919738027864 at the domain name, whatever the domain name provider domain name you have, That's how it will be coming. So later we'll look into that one when we pull. So I'll show you some debug command on that one, and the debug when we verify that one. So the call flows and everything. So I'll show you that one, how exactly the SIP, you know, address it looks like this one. Okay. So this is about SIP protocol. This is an overview of SIP protocol. Got it? SIP, it's a industry standard protocol. Again, one more thing, it's a industry standard protocol. Okay. SIP is a industry standard protocol. It is a peer-to-peer protocol. It works based on the request and response. It was developed by IETF, and it's a clear text protocol and works in the application layer, and it's a signaling protocol. So this is about, it's very simple, and it's very famous protocol because, okay, it support in many application and different vendor application. So it's not only the Cisco, you take any third-party unified infrastructure, it supports, and also it supports in many devices. It's not like only on call manager, only on the gateway. There are other different application devices. The SIP protocol is going to be support here, this one. Next, advantages of SIP. Dial plan configuration directly on the gateway, right? Since it's a peer-to-peer protocol, so the dial peer, if you want to create, we can be create directly on the gateway here. So whereas in MGCP, we don't have the concept of dial peer, everything has to be configured on the call manager, that one. So, but here, the dial peer for terminating the call to generating a new call leg. So we can be configure the dial plan on the gateway. Next, translations defined per gateway means some call is coming and you want to manipulate that number. From the provider, some calls are coming, and the gateway level, you want to be manipulate that one. For an example, complete DAD number is coming, but internally we have the 5 or 6 digit extension. Now that complete DAD, it has to be converted into the 4 or 5 digit extension. Then manipulation has to be done, that one. Now here we can be define that manipulation on the gateway. But coming to the MGCP, we don't have an option. If you want to manipulate that number, you have to be manipulate on the CUCM here, this one. Okay, similar to the H.323, how we can manipulate here, also we can be manipulate the number here, this one. Next, advanced support to third-party telephony systems. Say it supports not only to the Cisco, you take any vendor which is into the unified infrastructure, you name it, any vendor. You take Mitel, you take, okay, Alcatel Lucent, you take, Twilio, you take, or any other vendor, you take this one, Avaya, you take, any vendor, you take this one, the SIP protocol is going to be work. And so now, for an example, one end you have the Cisco, another end you have the third party, still you can able to be communicate with the help of SIP protocol here. Okay. Next, interoperability with the third-party voice gateways. Okay, not only to the telephone system, the gateway also. For an example, you have this Cisco call manager, the gateway you have HP gateway, not the Cisco gateway. Still, you can able to be, okay, able to be communicate between that HP gateway to the call manager here, this one. So that's what. See in the diagram, you can see that one. See, I'm having the CUCM, this one. This is the Cisco Unified CM. This is the CUCM cluster. Then this UCM cluster can communicate to the other product, other vendors. For an example, IPPBX. IPPBX means that's a third party PBX system. Third party, like how CUCM we have in the Cisco. If you go to the Mitel, they have the different product. If you go to the Avaya, they have a different product. Okay. So similarly, so from the CUCM to the any other third party vendor, unified call manager you want to communicate, you can be communicate. Next, the gateway. So from the CUCM to the Cisco gateway also you can communicate. Now CUCME also we have, which we have not discussed actually, but earlier there was in a CUCME concept. Now suppose you have a CUCME, from the call manager to CUCME you want to communicate, then again you can use the SIP protocol. Means between the gateway to CUCM, third party vendor PBX to the CUCM or the CME to CUCM, in between to communicate we require the protocols. Okay, which protocol we can use? SIP protocol. Now you can take the IMP server or Unity connection server, okay, or any other server between call manager to Unity connection, call manager to IMP server, call manager to any other application server. Still we can use CUCM, sorry, SIP protocol here. Okay, then we have a two different clusters. Between that also we can use the SIP protocol, or we have the another one, session manager cluster. Between the SME and the CUCM cluster, if you want to communicate, again you can use the SIP protocol. Again, you want to communicate to the provider. Okay, so service provider you want to communicate, then again we can use SIP protocol. So because of this, it's a very famous protocol. You take any infrastructure, any connectivity, any device, so we can able to, means not only here this one. Now you have an IP phone. IP phone wants to be communicated to the call manager, SIP protocol we can use. Call manager to the gateway, SIP protocol we can use. Gateway to the provider, SIP protocol we can be used. Two different CUCM cluster, SIP protocol we can be used. Two different vendor, one end Cisco we have, another end Avaya we have. Still we can use the SIP protocol. Or within the Cisco we have the other application, Unity connection you have. From the CUCM to Unity connection you want to communicate. From the CUCM to IMP server you want to communicate. Again we can use SIP protocol, this one. Okay, this is how what happened this one. So you take any device in between that one, if you want to be communicate, SIP protocol we can use. So that's the reason it's a very famous protocol, and many of the organization they implement this SIP protocol. Got it? That's an advantages of SIP protocol. Next we'll look into the architecture. So here, when two devices are participating, and if the two devices are using the SIP protocol, both the end, if it is using the SIP protocol, so then here we call it as a user agent. Okay, so any device participating in the SIP protocol, for that we call user agent. There are two roles we have. One is the user agent client and another one is the user agent server here, this one. It's very simple. Okay, we have the calling party and called party. Okay, always the calling party will be act as the user agent client, and the called party will be act as the user agent server. Now suppose CUCM you have. Now CUCM is the user agent client or user agent server. It can be anything. It can be anything, that one. Not only client here. It can be both. Suppose from the CUCM, if the call is going, then it's a client. If the call is coming from the gateway to the CUCM, then it will act as a server. So that is what the architecture we have, this one. Here, the peer means neighbor. Okay. It will be called as a user agent client. So one is the user agent client and another one is the user agent server. It can be anything. It can be user agent client and server. It's very simple. Calling party will be client. Called party will be server. That's it. Okay. We have a concept of master slave, client and server in a MGCP protocol. Always gateway is the client, CUCM is the server here. But in 8.323 and the SIP protocol, both are peer-to-peer protocol. So when it is a peer-to-peer protocol, but in 8.323, we have a concept of master and slave. Okay. But here we have the concept of user agent client and user agent server. Next, the SIP servers. These are the different servers we have: proxy server, redirect server, registrar server, location server. Okay. It's very simple actually, or what exactly all this is. Generally, we are not configuring any server. Whenever you go into the production, something you want to be implement, so some default configuration we have. Suppose what you want to configure on the CUCM, what you want to be configure on the gateway, some configuration where we are not defining that one, whether this server is a proxy server or redirect server or something we don't have. Yeah, okay. Separately, you want to be configure the most of the time what happens, this redirect server and proxy server, it will be using in service provider end, not on the customer end here, this one. Yes, if you want to implement on the customer end also, you can implement, but nobody is going to be implement on that one. Most of the time, this proxy and redirect will be implemented on the provider end here, not on the customer end here, this one. So that's the reason whenever you see, you will be not looking what exact, but explicitly we are not mentioning that who is my server. Okay. Who is my server? What happened here, this one? Now you have an IP phone. IP phone you are registering under the call manager. Suppose this IP phone using the SIP protocol. For this IP phone, the call manager is the registrar server, because my IP phone is registering where? On call manager, it's registering. For that IP phone, CUCM is the registrar server. That's how we have the concept here. But yes, in the production network, see here we have in the slide, whatever the things we are discussing, very simple things we are discussing. But if you go into the production network, there is a separate concept. We have this one. You had to be understand, because the SIP, the configuration, how we have this one, depend on the country. We have this one. Some country we have very simple configuration, but some countries what happens, some we have some extra configuration, like countries like where tri rules we have. Okay, telephony regulatories regulations, wherever we have this one, that's a different concept. We have this one, and generally we will not call it that as a SIP trunk. We call it as a PRI SIP. You are aware already, PRI T1 E1. Okay, that's a SIP protocol it uses, but it's not exactly the SIP trunk. It's a PRI SIP, that one. Okay, what is that PRI SIP? How, why we call it that one? What difference to the normal SIP trunk to the PRI SIP? Okay, how the configuration is the difference, that will be discussed. The countries like in India, okay, then Singapore, then Hong Kong, Tokyo, China, Dubai. So there are many other countries in what to say, in Asia, and even in the Europe also. If you go, I think Turkey, Kafar Saba, that's Israel. Okay, there are countries we have where tri rules we have. Because of the tri rules, what happened? This one you cannot implement actual normal SEP trunk, where everywhere we configure the PRI SEP trunk, that one. Okay, so what is that PRI SEP trunk? Okay, how the connectivity comes and everything, I'll be explaining you in the upcoming slides, or else when we do the practicals, I'll be explaining you that. I'll show you the two different configuration, how exactly it looks and everything. This one. Okay, the first one is the proxy server. Uh, Proxy server is an intermediate component that receives SIP request from a client and then forward the request on behalf of the client to the next SIP server in the network. So what exactly, in general, what exactly the proxy server, I'm going to explain you that one. So I'm not explaining you about SIP proxy server. In general server, I'm telling. Okay, so generally what happened here, this one, if there is a proxy server, or take it about IP phone itself. For an example, I'm having a call manager here. Okay, that's a CUCM. And the IP phone is registered under this one. Now, here I'm having one proxy server. This is a proxy server. Then I have the destination, some other server here. Okay, this is the destination server. I'm having this one. Now I'm calling from this phone somewhere here in the destination. Now, who is the source? Who is the destination here? So calling is the source, and this is the called is the destination. But CUCM will back to the source again here. Why? Because here to here is the one call leg. But again, the call leg will be generating from here. So when it is sending, what happens? The request first, it goes to the proxy server. Here, it's going to modify that source information. Okay, then it will be sending that information to the destination. When it is sending the information to the destination, now this proxy will be acting as a source, and this is the destination. Now, in between, what happened? This one, if there is any attacker, here, this one, if the attacker attacks this network, and if the attacker is collecting the information, attacker is collecting the source and destination information. Okay, now the destination you have, but who is the source? The proxy server source it will be, but actually the proxy is not a source. The CUCM is the source here, this one. So that's how what happened this one. For security reason, what we do, we use the proxy server. For security reason, we do what? Proxy server. So generally what happened, you are trying to connect some websites. It's blocked here. Okay. Now what people they do here, they connect to some US server. From there, they try to connect to the servers through the VPN. That's like proxy, they are doing that one. So all this thing for the security reason, we do that one. So in between the source and destination, or whenever to connect to the any server, before to read the server, in between they place one more server as a proxy server for more security reason. That's it here. Now here also we have the concept of proxy server in the SIP. But see, as I have discussed you earlier, all this server generally we will not implement on the customer end. We implement on the provider end here, this one. How exactly the provider end? Say I'm having a topology like this. Example, this is my CUCM. This is the CUCM I'm having. And the IP phones are registered here under this CUCM. Then we have a gateway. Okay. And this gateway connected to ITSP. Right? This is the gateway is connected to ITSP. Here in ITSP, you will be having the many servers. So what happened this one, when you are connecting from the gateway to ITSP, first it will be connecting to the proxy server. Then from the proxy, the backend, they'll be having a different server. Generally, we call it SBC, Session Border Controller Server. Okay, SBC server here. So whenever from the gateway, when it is connecting to the ITSP, it will be connecting to the ITSP proxy server. ITSP proxy server, this one. So why they have installed the proxy server? For security reason. After that proxy, it will be connecting to the different server. Someone is going to attack. They try to attack to this proxy server. But actually that information is not there in the proxy. It's there in the backend, some other SBC server. Generally, we call it SBC, Session Border Controller Server. This is how we call it. So that's what the proxy server in the production network, how we are going to be implement here, this one. See, it is an intermediate component that receives the SIP request. Means if any request is, suppose if I'm using this as a proxy, it takes the request, okay, then it will be generating and reaching to the destination on behalf of the source. Now, who is the source? This gateway is the source here, this one. So that's what the proxy server. But we have two types of proxy server: stateful proxy server, stateless proxy server. It's very simple. What is the stateful, stateless? Whatever the request is coming, if there is a proxy server, for example, I'm getting a request from here. Okay, let's take it on the provider end only. Whatever the request I'm getting here, this one. Okay, now it's depend what type of proxy you have configured, stateful or stateless. Stateful means if it is a stateful proxy server, it's going to keep track of all the records here. It's going to store, then it will be forwarding here. Okay, for the feature purpose, it keep the record here, this one. Stateless means it's not going to store locally any information, just it will be forwarding. Here in the stateful, it keep the record of that information, it stores in the local cache, then it will be sending the query to the next server, whatever the server it's having. But in the stateless, what happened? Straightforward, it's not saving anything in the local cache memory or the any server. Straightforward, it will be sending that one. That is the difference between the stateful and stateless proxy server. Stateless proxy server. A stateless proxy server simply forward the messages it received. This type of server does not store any information of the call or transaction. Means if anything is coming, just it's forwarding. Okay, it's not storing any information locally, that one. But stateful proxy server, it keeps track of every request and response that it receives. Means every information, whatever it's sending and receiving, all that information it keeps stores locally on that server. Okay, it can use the stored information in future. It requires, it can transmit the request if it does not receive a response from the other side. Means for the future purpose, so it's going to be store that one. So this is about the stateful and stateless proxy server. Got it? Next is the redirect server. Do you know the concept of call forwards? It redirecting that actually here, this one. Similarly, it works here. Say, this is my calling. This is my call, mean the destination. Now the call is hitting from this IP phone to the gateway. Then this gateway doesn't know the who is the destination, how to reach. Always it goes to the redirect server. Here you can see the call flow. When I'm calling, the invite message is sending from this gateway to redirect server here. Now redirect server will be providing the destination information, how to contact to that one. See, it's invite moved. Okay. Now the redirect server providing the information of the destination. Then this gateway is connecting to directly to this gateway. Again, the call flow is happening. This is what the redirect server. So in this gateway, we have not defined who is our actual destination or how to read the destination here, this one. So always, whenever you make a call, always the call goes to the this server. From here, you get the information how to connect to the destination. Then again, it will be generating a new call leg and it will be sending the invite message here. So that's what the concept of redirect server. So now I am not aware that where exactly this redirect server they use, where they configure, how, whether on the provider end how they configure. I'm not aware that one. So anyhow, on the customer end, we don't have the anything. We don't have the any kind of setup like this one. But in the production, in the provider end, I'm not sure. Yes, provider end proxy we use. Even the customer end also, for the contact center we use the proxy, that one. SIP proxy we use it. Generally the call comes, it will be hitting on the gateway. From the gateway it goes to the CVP. That's how we have the concept. But the redirect, I don't have any exact example where exactly in which scenario they use this one. But yes, generally call forward, call transfer option, it works in the base, in the concept of the redirect, that one. Why? Because whenever if I want to be called to this guy, so you will be not calling to that guy directly. It will be call is coming to me from here. It's a transferring that one or forwarding the call to that one. That's how we have a concept here. But still we have the concept of redirect server also. Redirect, always the call first, it will be hitting to the redirect, and redirect will be providing the information of the destination. Based on that information, now the source will be connecting to the destination. So that's the redirect server. Clear? Next, register and location server we have. Okay. Location server means if any phone exactly where it's registered. So that gives a almost register and location almost same here, this one. Example, it's a depend here, this one. Now register server, you have this one. Register server means, see, now I am having a CUCM. Then there is an IP phone here. Now IP phone got registered under the CUCM. So now I am using a SIP protocol here. So for this IP phone, the CUCM is the registrar server. Why? Because where we register the phones, where the IP phone is getting registered here under the CUCM. Now for this IP phone, the CUCM is the registrar server. This is the one concept we have. There is another concept we have, this one in the registrar server. So what exactly that? I'll come back. So if you want, you can look the definition. Receive the request from user agent client for registration of their current location. Registrar servers are often located near or even collected within the other network server, most often a location server. See, almost location and registrar are same. Means relocation server will define where exactly the endpoint got registered here, this one. Okay, that's how we have this one. So I'll give the another example for the registrar server where exactly we use the registrar server. This is the call flow we have. Okay. Okay. All right. Generally, how exactly the setup of SIP trunk comes means, see, you will be having the CUCM. This is my CUCM. Then all the IP phones are registered here under this CUCM. Then there will be one voice gateway. Generally, what happen? There will be ISP, Internet Service Provider, Internet. Okay. There will be an internet connection to this gateway. This is not PSTN or ITSP. This is an internet, normal internet connection. Somehow, this router there will be a internet. There will be a internet here, this one. Okay. Now internet, obviously how? There will be some connection, internet connection. Now, when they have provided the internet, what happened? Now home connection, have you seen the same ISP? You are grabbing one connection and you'll be installing one modem. From the modem, it's connecting to your laptop, or it's connecting to your phone with the wireless, something. This is how it will be having this one, right? But when you are getting a internet, you don't have any IP address here. IP address means static IP address you don't have. You have the dynamic IP address. Here there will be one DHCP server that will be providing this one. But coming to here in the corporate offices, they purchase one static IP address. They purchase what? Static IP address. For an example, I'm taking one IP address here. Okay. So some static IP address, you can take it. Example 150.96.72.7. This is the IP address that's provided by the provider, and this IP address we have assigned here. However, whatever the interface you have connected, either serial 0/0 or gigabit 0/0, whatever, wherever you have terminated that one, on that interface we have assigned this IP address, static IP address. Okay, you go anywhere, any organization, whenever they take the internet, it's not like a home connection. You know, home connection, something, the cable they are grabbing and terminating on the modem, and from the modem with the wireless you are connecting to the different devices. Not like that. Okay, in production what happened, this one, when they are grabbing, yes, again I'm not explaining you exactly the connectivity. There is a concept of mux. Okay, whenever you grab a connection, it will be terminating on the mux. From the mux it will be connecting to the gateway here, this one. Okay, so when they have connected here, this one, so they will be provide the static IP address. That means it will not keep on change this one, because you have purchased this IP address and assigning. Now this gateway is getting the internet. That's how actually the connectivity comes in the production here. Now, now you want, whenever the call is coming, now call will be not route via this connection here, because this ISP, this provider is providing only internet connection. It will not providing the telecommunication service. For this one, now I have to go to the other provider. It's called ITSP, Internet Telephony Service Provider. Example. Okay. Let's take an example. That's a depend on the country. Okay. Different country, different providers we have. In India, if you come, Tata we have, Airtel we have. That's very famous actually, Tata and Airtel. Then other Vodafone also we have, Jio also we have, Act also we have this one. But very famous, most of the organization, you go anywhere, they use Tata and Airtel as a provider for the internet here. Okay. Now depend on the country here. Now for the telecommunication, we have the different providers. Yes, most of the time, the same provider, they provide both the services. Now in India, for any corporate office, they want internet, they go with Tata, or they go with the Airtel, or they go with the Vodafone here. For telecommunication also, again they go with the Tata, Airtel. This is how they will go, that one. But in the other countries, so we have a different provider. We don't have like a Tata or Airtel. We don't have this one. Okay, we have a provider. For an example, if you talk about London, yes, London, that's in UK, we have a provider called Dicey. We have different countries, different we have. Colt, Singtel. Singtel, it's in very famous in Singapore. Okay. Then PCCW. That's in Hong Kong we have. Okay. Dicey, Colt, Singtel, PCCW. But if you go to the US and Canada, the very famous provider is Lumen. Lumen is the very famous provider. Okay. That's how we have this one. Now you are going to this IT service provider, telling that one, I want a trunk connection. I want what? Trunk connection. Now this ITSP, what they are doing, They will not grab a cable and connect directly to your router. They will not providing like this. They will not provide okay. Whenever you want trunk connection means from the ITSP, they will not grab a connection and they will not provide that one. So it will be not like this, where for the ITSP, okay. Now what happened this one, they will provide the connection. How they will provide? I have to give my internet IP address to them. Already I have the internet, existing internet, right? Internet to reach this gateway over the internet. This is the IP address I can use 150.96.72.7. So with this, I can be reached here. If I provide this IP address to this ITSP, if any call is coming, it will be transferring that call to this IP address. This IP address is public IP address, and this is the static IP address. Through the internet, it can be routed, right? Now it goes here. It will be connecting to this one. Okay. Now the provider means telephony provider, they will not grab any cable. Understand carefully. Already there will be an internet to that gateway. Whatever the existing internet they have and whatever the IP address you have on the gateway, okay, if you provide that IP address, the call comes to that one. So that is how actually the connectivity comes. That is how actually the SIP trunk works. Got it? Clear? Now, coming to India. Okay. Now you have the ITSP. So this is the same CUCM I'm having, gateway I'm having. Yes, now it's up to you whether you want internet or you don't want internet. You want to keep it internet, you can keep it. You don't want internet, you can remove. It's up to you, that one. Even if you have a internet or you don't have a internet, whatever it may be. Now they are not bothering whether you have a internet or you don't have an internet. Okay, now in India, for an example, we have Airtel or we have Tata. These are the providers we have for the telecommunication. Yes, I want SIP trunk. Now they grab and they will connect a one physical connection to this interface. Physically, they'll connect. They'll taking one cable. Physically, directly, they are connecting on to your router. And now they will provide one IP address. See here, and they will provide one. For example, 10.2 here they are providing. Here they provide 10.1. They provide separate IP address. Even you have internet, they don't bother about that one. They won't care about that one. Whether you have internet or you don't have internet, they won't bother about that one. Okay. Here in India, if you want a SIP trunk, directly they'll bring one cable and connecting to your router, and they assign one IP address. One IP address, it will be there on the provider end, another end they provide. And through this connection, it's not an internet. It's not a internet. It's an ITSP, that one. Okay. So with that one, I want to browse, I want to get an internet. It's not possible. Only for the calling we use that one. That's how the SIP trunk we get it in India. Not only in India, there are countries like India, Singapore, Hong Kong, Tokyo, Dubai, Turkey. There are many countries where we have, telephone regulatory, some restrictions we have. So everywhere, if you talk about the SIP trunk, this is called now PRI SIP. PRI means what? Physically, one cable they'll be grabbing and connecting, right? PRI connection, it's like same thing. You go to the provider, again same. This again Airtel and Tata, they have the PRI connection also. PRI means they'll be grabbing one cable and connecting to the router, where they are connecting on the even interface. Now they are not connecting on the even interface, they are connecting on the gigabit Ethernet interface. That's what the difference. In a PRI, what happened? For the PRI, we have a dedicated modules, T1 and E1. If the PRI connection means it has to be connect on T1 or E1 only, that one. But coming to the here in the SIP trunk, not required T1, E1. Whatever the other port you have, any Ethernet port you have, that can be connect on the Ethernet port. Again, in the T1, E1, we don't have the IP address. We are not assigning any IP address. But here, we are assigning the IP address. Routing has to be enabled. Everything has to be done. This is how the trunk setup we have here in India. But other countries, it's not like that. Sometimes what happen? Centralized SIP trunk we make it. Means we have multiple locations. In every location, we will not install gateway. Of course, internet will be there. Okay, with layer 3 switches, internet will be there, and internal communication will be there. Internal trunks will be there to communicate from one office to another office. So there is a concept of SD-WAN. Okay, SD-WAN, where we used to connect from one location to another location. So for the SD-WAN, the technology is different, devices are different, and the engineer is different, where most of the time the network or security engineer will be take care about the SD-WAN connectivity concept as a voice engineer. So we will not work on the SD-WAN concept here, this one. Okay. So it will be there. Every company SD-WAN will be there. Okay. Now, for an example, I have 4-5 locations. It's a very small offices where I have 10 phones, 20 phones, 40 phones. For that reason, so they will not install one dedicated router. They will not install that one. There will be one high-end model router in some location. All that other locations, okay, this one ITSP connection, it will be terminating in one single location. The call comes first from the provider, it goes to that router. From the router, from the internal network, it connects to the particular location. That's all. For an example, we have office in Bangalore, Chennai, Hyderabad, Pune. Okay. So Pune, Hyderabad, Chennai, it's a small offices. Bangalore is the big office. Now we have installed the gateway on the Bangalore. Pune, Hyderabad, Chennai, we don't have the gateway. But still we have the phones and we require the connection there. That all the Pune, Hyderabad, Chennai calls will be terminating on the Bangalore gateway. Okay. Why it's possible? Because their SIP trunk means not required to grab the cable and connect. You just have to give the IP address. It can be anything, anywhere. You keep it router anywhere, they don't bother. Okay. Just you are giving the IP address of that gateway. It should be routable in the public network. So now I'm giving the IP address of my Bangalore router. Okay. Pune call also coming to Bangalore, Hyderabad call also coming to the Bangalore, and uh, Chennai call also coming. Means from the provider it comes. For example, you are dialing. From your, it goes to the provider. From the provider, next hop is who? Bangalore. It comes. From the Bangalore, it goes to the internal network to the Pune. Or it goes internal network to the Chennai. Or it goes internal network to the Hyderabad. That's how the connectivity comes. This type of setup, it's not possible to do it here. This is only for example, for your reference, I have given Bangalore, Chennai. This type of setup is not possible here in the Asia countries because of the telephony regulatory. But you go to the this one, European countries, it's possible. Okay. For example, you have Madrid, Germany, any location, Spain, any location, that can be terminate any locally, that one. Because there we are not grabbing a physical cable. But here in India or Singapore or Hong Kong, you go anywhere, they grab physical cable. They'll get one cable from the provider and connecting directly to your router. So that's the reason it's called PRI SIP trunk. That's how we have a two concept. Got it? Got it or not? Now, when you have this PRI SIP trunk, okay, see, I am having a ITSP. I have taken one cable and connected to the on the gateway. In this scenario, whatever this router you have, right? This router, this is the gateway. This router has to be registered under the provider. The router has to be registered under provider here. It's a mandatory. Okay, now I'm taking one more. This router on the provider end, there will be one server here. In general, we call SBC, Session Border Controller Server. Okay. Now this router first, it has to be registered here. Now this server is called what? Registrar server. Not only IP phone. For the IP phone, the CUCM will act as a registrar server. Even for the gateway, we have a registrar server. Before the call got established, this gateway has to be registered under the registrar server. Where this registrar server comes? Under the provider end. When we have this concept, registrar server, when you have a PRI SIP trunk. physically getting a cable and trunking. But for normal SIP trunk, where over the internet just we are providing, they're not required to register. They're not required to register. But here, it has to be registered manually. For example, Bangalore, if you are taking SIP trunk, first your gateway has to be registered. You go to Singapore, you go to Hong Kong, you go to Dubai, you go to China, you go to Tokyo, every time, okay, we have a PRI SIP, and that gateway has to be registered under your service provider. Until it is not registering, it will not work. Okay. Now to register that gateway, now that's we have registrar server. Got it? How the registrar server comes? For the IP phone, CUCM is the registrar. Even for the gateway, provider and we get a registrar server because that gateway has to be registered, but not in all location. Wherever we have a PRI SIP, then only the registrar server. Got it? That's how we have a different server: proxy server, redirect server, register server, and location server. Any doubts, any questions, guys? That's what the register server and location server. Clear? Any doubts, any questions on the servers? Next is the SIP call flow. We have three types of call flow: early offer, delay offer, early media. You remember on the H.323, slow start, fast start, and early media. Here also we have early offer, delay offer, and early media. We have this one.